Okay, we'll give this a shot and see how it goes. So here is the math review worksheet. We're going to start with some unit conversions. So the prefixes that we're using, you will not have to memorize these. These are on your equation sheet. You just need to make sure that you know how to use them. So we're going to start by converting from kilometers to centimeters. So you want to start with this written here. And then keep in mind you want to keep it over 1 so that we make sure that we have everything lined up correctly. And then you want to go from kilometers to meters is what most people know. So I'm going to go 1 kilometer is 1,000 meters. So you'll see the kilometers on top will cancel with the kilometers on bottom, and you will end up with meters. We're looking for centimeters. So then we need to go from meters to centimeters. So 1 meter is 100 centimeters. So then that's gone. And then you just multiply across the top. So you end up with 270,000 centimeters. So you can leave it like that. Or if you prefer, you can turn it into scientific notation. And we can make this into 2.7 times 10 to the 5th centimeters. That's both acceptable. We don't really care unless I ask for something specifically, but it's just whichever one you like better. Now, the one that people usually have trouble with are the cubics. So cubic just means it's 3 dimensions, which means like a cubic centimeter is 1 centimeter by 1 centimeter by 1 centimeter. So there's 3 different dimensions in that. So if we have cubic meters, we need to convert all 3 of those meters to centimeters. So if you have 0.372 cubic meters, what that means is that meter is in there 3 times. So you need to convert from meters to centimeters 3 times, 1 for each one. So you essentially need meters to centimeters, meters to centimeters, meters to centimeters, because that's something that's cubed. And so you need to cancel out them 3 times. Now, if you want to, you can just write it once and then make the whole thing cubed. That's totally fine. But all 3 of them are going to be 1 meter equals 100 centimeters. So then that cancels all 3 of those, and you're left with 3 centimeters on top, which means your answer is going to be in cubic centimeters. So that one comes out to 372,000. So again, you can use it like this, or if you want to put it in scientific notation, it's going to be 3.72 times 10 to the 5th cubic centimeters. So again, either one's fine, just depends on which one you like better. The other one people tend to have trouble with, which by the way, I picked the hardest ones here, so no worries if you had trouble with some of these. So we're trying to find an answer in kilometers per hour, and we have meters per second. So there's 2 different dimensions, a distance and a time, that need to be converted. So we're going to start with the 28 meters per second. And what that means is just you go 28 meters in 1 second. You can put a 1 on the bottom here if you would like. If your S's and your 5's look similar, I would write SEC, it doesn't matter. So we have to do 2 things. We need to convert meters to kilometers, and we need to convert seconds to hours. So it doesn't matter which one you do first. So I'm going to do meters first. So I have 1,000 meters in 1 kilometer. So then I've got the meters canceled. So now I have kilometers, which is what I want. So the distance part is done. So now I need to do the time. So seconds to hours, we're going to do that a lot. So if you remember the number of seconds in an hour, you can do this in 1 step. I'm going to do it in 2 because it's been a while. So we're going to go from seconds to minutes first. So we know there are 60 seconds in 1 minute. So that gets rid of our seconds. And then we need to go from minutes to hours. So there are also 60 minutes in 1 hour. That gets rid of our minutes. Now again, if you do these a lot, you will just look at this and know that it's 300 3,600 seconds per hour. You can jump to that, it doesn't matter. So then we end up with 100.8 kilometers per hour. Now we like to round, so we have 2 sig figs in this. So 2 sig figs in this is a little tricky to write. So I've seen it done a couple ways. You can put like a little line over the 0 to say that this 0 is significant. I've seen that done. If you're unsure, you can always do scientific notation, because in scientific notation, this is how you would write that with 2 sig figs. So again, either one is fine. Okay, now trig. This is what people were having the most concern about, I know. So remember, we're always using right triangles. So keep in mind, this is SOHCAHTOA. So I like to write it like this. I think this is helpful. So SOHCAHTOA. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. And so we use an angle, and 2 sides, they all go together. So if we're trying to find this side, we have this angle. That is the one that is adjacent. So if it's adjacent, we're going to want cosine. So we can start with cosine 35 equals, and it's adjacent, which is the one that touches it, which is our x, over hypotenuse, which is the 45. So we just put it there, and then you solve for x. So you should need to multiply by 45 to get it up top, and you get 36.8618. So that's our answer. We do need to round it. We've got 2 sig figs in both of those, so I'm going to keep 2 here. So that means this is my last digit that I want to keep. So that's going to be 37. So this is going to be 37. And then if you have this, whatever this has as far as units, your sides are going to have the same thing. So if this is a speed, this is a speed. We're going to do a lot of this when I think we get to module 3 and 4. We won't do it for a little while, so if you need some help on this, you have some time. So then we have to find the other one. This is the opposite one, so we're going to use sine. So sine 35 equals opposite over hypotenuse. So our opposite is y. Hypotenuse is 45. So y equals 45 sine 35. And that comes out to 25.8109. And make sure your calculator is in degrees. If you're not getting these numbers, it's probably because you're in radians. So double check that. So again, this is your answer. This is our last digit that's meaningful. So we're gonna make that 26. It's gonna be 26 and the same units as our original measurement. It's gonna be meters per second. So then this is the opposite direction. So this one, we knew the hypotenuse and the angle. This time we know the 2 sides. Both of these are going to be things we do a lot in a couple units. So you will want to make sure you know how to do these. So to get the hypotenuse, you do Pythagorean theorem, which is your a squared plus b squared equals c squared. That you probably thought you would never use again. So we're going to do this. We're looking for c. So a and b are just the 2 sides. It doesn't matter which one. So 4 squared plus 14 squared equals c squared. So we get 212 equals c squared. So c is the square root of 212, which is 14.5602. So then again, same thing. We got your sig figs. Now this one, unfortunately, I gave you 1 sig fig on this. So this has to turn into 10 kilometers. Put that there. And then here for the angle, we have the opposite and the adjacent. So we're going to do tangent. Technically, you could do any of them because you now have all 3 sides. It's always best to start from the numbers you were given in case you messed that one up. Then it doesn't make your angle wrong too. So tangent is opposite over adjacent. So your opposite is the one across, which is 14. Your adjacent is the one that touches it, which is 4. So you get tangent of theta is 3.5. And then to find the angle, you do the inverse tangent. So on your calculator, it looks like tan to the -1. And then you would just type in the 3.5. And then your answer to that is going to be 74.055, which again, unfortunately, is going to round to 70 because I gave you 1 sig fig. If you see me do this, it just means I'm rounding it. I would advise you write this number down and then round it, because a rounding error is not as big a deal as getting the wrong answer. So when I give partial credit, I'll give you more for that. And then the last thing is solving algebra equations. Now, granted, these are probably more difficult than 95% of what you're doing, but if you can do these, you can do the other ones. So in all these, we're looking for x. So remember, when you're solving an equation, you want to solve for things in the order that is like the opposite of order of operations. So the first thing you want to get rid of is anything added or subtracted. Now, I can't do this yet because it's in parentheses. So then I'm going to do multiplication. So this C and D, I need to move them. So they're multiplied now, so I need to divide. And whatever you do to one side, you've got to do to the other. Then that turns into A over B, C, D on this side. And then on this side, these have canceled. So then we have just X minus, that's a minus, E. And then to get rid of the E, you just add it to both sides, because it's the opposite of subtracting, and you get x equals E plus A over B, C, D. Now it doesn't matter which one you write first, the E or the A, B, C, D part, because they're added. So whichever order you have it in is fine. And then the next one, I'm looking for this x. So again, first thing we want to do is any adding or subtracting, so we're going to move this f over. So to add that to both sides, so then that goes away. So you have x squared equals f plus g squared h over j. Again, it doesn't matter which order you write them in because they're being added. So we take this, so we need to take the square root of that. You cannot get rid of this squared because these are being added. If this was all multiplied, you could get rid of the squared and pull it out, but you can't do it here. So really, all you can do is stick everything in a square root. I also like to just make everything one fraction because I think it looks better. You don't have to, you could keep the G, H, J part separate like that. And the last one, we're looking for x. This is something people mess up a lot. If x is on the bottom of the equation, then you have to make sure that you get it up top. You don't solve for 1 over x. Or you can solve for 1 over x as long as you flip it at the end. But most people forget that. So I'm going to move the n over first. Get k plus n equals L m over x. Now I want the x on top, so I'm going to move that here. Make sure you remember this has to all be multiplied by the x. So that's gone. I get x times k plus n equals Lm. And then I need to get rid of this. This is being multiplied, so I divide by k plus n. And then that cancels that there, and I get x equals Lm over k plus n. That is my answer. So again, these are like the hardest versions you could get. Most of them are going to be easier than this. But I just wanted to see how we're doing with our algebra. So let me know if you have questions, and that's it for this one.